So, hello everyone. Hi from Czech Republic, from beautiful city Prague. Today our topic is the specifications as a better way of development. And first of all, I want to start with a quick introduction. My name is Artem, and I'm a software engineer with over a decade of experience in software development of any kind, from typical web services to game development and mobile applications. So I have some experience and I'm really excited to share it. Currently, I work at Microsoft. In my free time, I try to actively contribute to open source projects because I feel this is really important for the engineering world. Besides, I consider myself a technical diversity advocate, so I encourage people to try new technologies in their daily work, maybe new languages, new stacks, everything. First of all, I want to highlight that this talk will not be about the code in the first place. We will cover some practices that can be used to improve our development experience and software architecture experience, regardless of particular language or stack. Here's what we have for today. I'll start with a bit of introduction into a theory, which is going to help us to follow the presentation. Then we'll spend some time reviewing what methodologies we can apply and what kind of tooling is available out there. And of course, it will be reflected by checking out some real-world problems, some solutions, and of course, benefits you can get out of it. There are a lot of things to discuss when it comes to specifications in engineering world. But what is the specification actually? Let's establish the meaning, the key meaning, before we can move forward. Some time ago, I was checking different articles, and I found this particular quote that I really liked it. Because it actually reflects the meaning of the specifications in the development process. So it says, software engineering is the art of turning specifications into miracles. And the meaning of this quote is that if you have proper requirements and instructions, you can build literally any software that might be a miracle for someone. And I think everybody knows that it's true. Nowadays, we have so many applications, and some of them are really miracles. Even this OpenAI thing, and basically this is the chat, and we can talk to someone, and there are some replies. So a few years ago, or maybe several decades of years ago, you can say that it's a miracle. Okay, but let's take also a look at the original definition of specification word, which I copied from the Oxford Dictionary. Here we have that specification is a detailed description of the design and materials used to make something. Please note that it's not a description of how something works. It's an instruction on how to make something. With this being said, we can finally move forward and check the specification examples in the real world that we can use for development. There are several types and even subtypes of them. For example, we have functional specifications or process specifications, which you can see right now on the left and right side of the slide correspondingly. It looks like we have quite a lot of them, and maybe some of these already seem familiar to you. I hope so. For example, before you start the development process or the building the architecture of your software, I suppose you expect some requirements that may be converted later into a design document based on which you can basically implement the product. It is kind of a specification. Another example could be when you have some API and you want to provide information about it to your customers or to other engineering team, you can use Swagger or API docs. It is also a kind of specification. And sometimes even a method signature in your code may be a specification, depending on how you look at it. If you provide the interface to the developer, It describes how to implement something, so how to make something to work. It is basically a specification. Let's take a closer look at one of the most popular specification in web development, which is OpenAPI, also known as Swagger. I bet that everybody who is related to web development knows this thing pretty well. But let me quickly introduce it to you in case you don't know. OpenAPI is a specification that allows developers to define what API looks like and what kind of operations we can do. Usually, it contains a list of endpoints with their data structure definitions, which allows other engineers to use it for integration development. For example, I have a service, and you want to create a service which will be connected to this one. So I provide you the OpenAPI specification, and you can write code based on this specification or list of endpoints or data contracts. A well-known situation is when backend engineers provide this OpenAPI to front-end engineers, or maybe to mobile developers to create a user interface or create a mobile application to work with this API. Of course, there are more usage of this specification, but I believe this is the most common case. And of course, it is not limited to only the communication between engineers, since you can also leverage this for your infrastructure configuration. For example, by checking what kind of authentication is used there, or you can even test your API by using some specific tooling that supports OpenAPI. And there are a lot of examples. But the main question here is, how does it help engineers with the development process or with the designing process of the architecture? And you might be thinking that if there is only communication help, then it's not worth it to introduce specifications at all. But it's not that easy answer. First, I think we should understand what kind of problems we're trying to solve here, right? Nobody wants to use a technology if it doesn't solve a real problem. And here I collected just a few examples of different problems we may face when working on modern services or modern architecture for our applications. Let's say that if you have client-server architecture or even server-to-server architecture, you will most likely have inconsistencies between these APIs or some data contracts. Especially when it comes to backward compatibility, it becomes even harder to maintain everything. The more complex your system is, the less speed of development you get. This is another problem which we want to solve. And if you had bad processes during the implementation or software architecture designing, you may have blocked front-end or mobile engineers awaiting the information from the backend team, which is also not very pleasant experience, especially for a huge company who wants to get the revenue. Also, in big projects, the cost of maintenance is usually very high, and even updating a small part of the project might be quite painful due to technical debt or some MVP solutions, and so on. So finally, we can think about probably the most important metric for everyone is which is time to market. We always want to improve our time to market metric. We want to deliver faster. We want to deliver with the higher quality. We want to deliver with less effort. And at the same time, by doing this, keeping the same quality level or even better is a very, very difficult and tough challenge. So one of the options here to solve all of these problems might be specification-first development, or specification-first approach, also called. You can encounter this approach also known as design-first. And it is a way of development when you start with a specification document before the actual implementation. And it might be any specification. Swagger, or maybe some particular document which fit your company standards. So I personally consider it as test-driven development for the API because it just helps me to understand the meaning of this specification-first approach. You start with a specification, then you prepare test cases based on it. But test cases not for your code, but for your system, for your business scenarios. You do some implementation with different technologies, and moreover, you can start work on both sides, let's say the backend and mobile app or front-end user interface. You can do everything at the same time. Once it is done, we can run our tests and probably make some minor adjustments because nothing works for the first time, right? And if we are lucky, after tests, we can say that it is done. Or even without minor adjustments if you're a perfect developer. This journey seems very efficient, but it is time-consuming to prepare all the requirements and write all the specifications and test cases in advance. Very few people like doing this way. I believe that not everyone wants to spend a lot of time before the actual result. So we all know how it works. In reality, we have much less probability that it will go that way. I saw hundreds of situations and different teams and companies that follow the other way. They start with an idea and maybe some design documents or maybe even some papers based on which backend team already can start the development. And after initial MVP or maybe some proof of concept version of the backend or the application, they can generate specification and from the actual code. And only after that, they include their front-end team or mobile team and syncing up with them and testing it on the way. This approach, which is the most popular nowadays, is called code-first development. Yeah, it works sometimes, but you can notice in the list on the slide that once you reach point number 7, there is still a probability that you may have several iterations of improvements and bug fixes. I believe this is one of the biggest problems in our development lifecycle. So what do we do to improve that? And I believe everybody already knows. The answer is simple. Just don't write code without specifications. Easy. So what's the reason why we all keep doing it wrong then? And I think here's why. Our industry dictates a different vision. Django, which is one of the most popular Python frameworks, has a package to generate specs from your code, but not the other way around. Flask, also popular in Python world, does the same thing. In Fast API Python framework, they did even include a generator as a core feature. And the same thing happens in other communities. .NET Core has a swashbuckle package that generates Swagger from your code. Azure Functions in .NET Stack as well has it as a core extension. And quite popular framework, Symfony, from the PHP world, also uses this first approach, code-first approach. And a lot of other examples. Trust me, I checked it. This is why I technical diversity advocate, because I checked a lot of things and I encourage people to do the same. So based on this list, we can say that basically code first won. I suppose, yeah, at some point, I also accepted this as the right way of doing things, until I encountered one specific solution. I will tell you a short story about the package named GoSwagger, which affected me in a good way. Some time ago, I was working on a microservice project based on the Golang language, and this package was used there to help with code generation. Sounds simple. Let's start with a couple of words about the package itself. As you can see from the name, it works with Swagger specification, which we also know as OpenAPI. But unlike other solutions I mentioned before, it provides more features focused on code generation instead of specification generation. You can start with a spec and generate SDK for your clients. Or you can generate the whole application with server stubs, including endpoints, infrastructure, authentication configuration, and even some tests for your API. So everything could be generated from just one single specification. And the only concerns you may have working with the package are support of the version 2, because currently OpenAPI is based on version 3, and the fact that it is written in Golang and is supposed to be used in Golang-based projects. The first release was 9 years ago, by the way, and it is still alive. So if you work with Golang, you can give it a try. And let's take a look at the example of what you will get by using this package or module. There is some command. I, on purpose, removed it from the slide because we're not interested in so much technical details. But long story short, after running this generation command, it will parse your specification and generate all the models from this spec as Golang data structures, such as the one that you can see right now on the left side of the slide. And it also will generate the whole application structure, which you can see on the right side. So it contains some entry points, models, definitions of the endpoints, and everything you need to write your application. This was a huge invention for me back then, and I was really impressed, but depressed at the same time by the fact that we don't have that everywhere. By using this package, I stopped caring about the endpoints boilerplate, creating DDOs, registering the configuration, and writing request parsers. Everything was generated automatically, and it was so much easier to design the whole application because I can start with a small specification file, and later I know that everything will be automated. So finally, I started thinking that specifications are not only useful for describing existing APIs for clients or for customers, but also for defining how to make this API, which is consistent with the definition I mentioned at the beginning. This, of course, inspired me, and I decided to take a look again and see what else we have there besides this package to leverage the power of specifications and bring my designing skills to the next level. And to my surprise, actually, there was a default, or let's say, kind of official package from the Swagger team, which provides a similar experience. You can generate both client and server code, and it supports more than 30 types of client SDKs and more than 20 types of server stubs, which means more than 20 frameworks, but not languages. It is totally customizable, and you can provide your own templates, server stubs, create extensions. And moreover, it also supports the latest third version of the OpenAPI. So let's say it is modern. The only concern, again, is the language, because Java is not used by everyone, so it might take some time to onboard yourself into this world. And right now it has just 16,000 stars on GitHub, which is surprisingly small number for this kind of package, at least I would expect. So that's not it. Later, I found another one, which is a community fork of the same Swagger package, but with more types of SDKs and server stubs. I believe in power of community, and that's why we still have open source, right? And basically, this is a good example because you have at least 2 times more support for different servers, frameworks, and languages. And it has around 20,000 stars on GitHub, I believe, which is better, but still not what I would expect from this kind of packages. So since I started diving into this world, I also found another interesting specification that goes along with the tooling for code generation as well. Its name is Async API, and that allows you to define asynchronous communication between services and storages. For example, you can describe what kind of information you exchange between Kafka and your API, or what messages go into Redis queue, and so on. Once you have your specification, you can generate SDK, you can generate consumer classes in any language you want. It is very similar to OpenAPI, but with a different purpose. It's also based on JSON schema, and this project is not popular yet, but I believe maybe after this event, it will be changed. So it has around 4,000 stars on GitHub. I already used it in several projects, and I would definitely recommend this one to try. Since this time, I already found a few more examples of different open source specifications that help with other features, like the feature toggling or cache storages, and I can spend another 30 minutes just describing them. So what's the conclusion here? If we can do the specification for API or a sync API, does that mean that it will work for other features as well? And I think so. Let's imagine you can define specification instead of the boilerplate code or templates in your project. You can apply specifications not only for API, but also for infrastructure. It is already supported in many clouds, and we have a separate term, which is infrastructure as code. Let's keep it as infrastructure as specification. You can generate code from these specs and remove it from your repository because it will be generated during build process. So you can save your developers' time. You can save your storage of the repositories if it matters, and do a lot of things like storing all these specifications in one place to make it available for everyone. Sounds good, right? So let's reflect. We have a lot of benefits, and basically specification-first approach can help you to make your QA engineers happy because they can write tests without any API. It can help you to make your engineers happy because there is less code to write, there is less code to review, and there is no blockers for different teams. So it will speed up the development process in general and reduce a lot of overheads and the number of errors due to inconsistencies, for example. You can reduce the communication and the amount of code, and it's everything about improving the performance of your team. But of course, we also know that there is no perfect solution. So we have to do some trade-offs, and sometimes it's not very pleasant, but still. Let's say the tooling which we have nowadays is very language specific. So it requires more effort to integrate it or to implement it in your project. These kind of applications are a bit tougher to refactor, especially when you need to change the generated code. Sometimes there is no solution compatible with all the projects. Yes, we have support for Redis, for Kafka, but sometimes there is some new project which is not supported by your specification yet. And of course, we have some limitations in the specs itself, so we may lose some small benefits of our top-notch technology stack. But you should keep in mind that code generation and this specification is just the templates or template engines, so it's not all powerful. But we can keep it more advanced and help to improve. So I shared a lot of benefits, but there was a task, small task, but interesting, that actually changed my mindset, and that is why I ended up here talking about the efficiency of the specifications. Let's quickly dive into this one. Back then, I worked in a platform team of some company where we had a task to create a catalog of specifications to let everyone easily generate SDKs. Unfortunately, we followed code-first approach. And as a result, we had some services that were generating specifications based on API, and not all endpoints were covered. So we decided to cover them manually and create a specifications catalog to solve this problem. I thought that it would make sense to check what are the options among open source projects, because that's the thing I always do. And for sure, someone already tried to parse and analyze this kind of thing. But apparently not. Back then, there was no package that would allow me to read all the endpoints from the specification and compare it with available routes in my application, for example, Django, Laravel, or Symfony, or any other framework. So here we go to another story about one more package, which is OpenAPI free parser. This time it was created by me with only one simple purpose: to read the specification as typed DTO, to allow me to read the endpoints, or to get the request body, or to do something really simple about this specification. And unfortunately, all the parsers I found, they just allowed me to read it as the dictionary, or read it as the file content, as a string. So I took some other projects and implemented my part on top of it to get this simple solution, as you can see right now on the slide. And actual solution for my problem was just a couple of lines of code. And as I mentioned before, this talk is not about the code itself, so I will omit the details about the business logic. So here we have just simple Python code that iterates through all endpoints in my spec and prints them in the console. And you can see the output at the bottom. And basically, that is how I solved my problem, by using specification and improving the build process by checking and validating that everything is covered. But in reality, by using such tooling, you can extend functionality even more. For example, you can create your own code generators. You can implement the server toolkits for mocking responses for QA engineers. You can generate fake requests for stress testing, and it will allow you to test your architecture even before the implementation. And if you do your own DevOps, you can introduce a lot of configurations in these specs, such as rate limits or virtual networks. And overall, there are a lot of ways to automate things and improve your development performance and experience. Once I finished my project, I decided to publish it as an open source. And you can imagine how I was surprised once different people started contributing their features and suggesting another solutions to solve their specific code generation tasks. Even companies were using this package as a part of their solution, including even Microsoft. So I was shocked back then. Right now it has around 25,000 downloads per month, and I'm glad that it helped so many people, but it's just a parser, right? Not a big deal. So that was my story, how I decided to incorporate specifications into my development lifecycle as more important thing. And answering the question, what's next, I would say it's just your imagination. You can introduce a lot of different new specifications for metrics, data, search, storage. It's up to you. And since right now there is a trend to use AI everywhere, that is also an option to leverage custom models to generate code based on your unique specification. So if you want to start experimenting with specifications to improve the development process, I have a few personal recommendations for you. Start with something simple. Try to not cover a huge system on the first try. It will let you get results much faster. Do not reinvent the wheel, as I did, and to some extent. Some tools may fit your platform already. Try to automate and generate stuff as much as you can, even simple stuff, but it will help your engineering teams to reduce the complexity. And we know that if something is optional, then it's not needed in reality. So try to enforce these techniques in your projects. To sum it up, I would like to say that there is no perfect solution that can solve any problem, but I love this principle: done is better than perfect. And that's exactly what you can do even right now. Don't try to solve everything with the specification, but try to optimize existing processes and solve real problems. Here I collected all the resources I mentioned during the presentation. Feel free to check them out. I hope that presentation will be available afterwards. And of course, don't hesitate to reach out to me in case of any questions. I would love to share more. And thank you, and see you later in the Q&A session.
Thank you very much for this presentation. Like, I'm impressed, for real. Well, I'm sure the community also.